Hello 8th graders, we are on lesson 3, session 3 in our books, which starts on page 55. And yesterday in session 2 we performed sequences of rigid transformations. Today we are describing sequences, so we're doing the opposite. It's already been performed and now we have to say what happened. And again, this is a develop lesson, which means we are developing our understanding under the guidance of a wise adult. So here is our try it. And ooh, look, one of my favorite games. Although these are not the traditional shapes, are they? Paula plays a game on her phone where she needs to fit shapes together. Figure J will fit, figure J is green. Figure J will fit into space J prime 2 only if the figure and the space are congruent, aka the same. Describe a sequence of two transformations that move the shape into this space. Okay, so let's see, how can we do this? Do we even need the space down here? I guess we need it for describing, don't we? Okay, so you can probably already see that this fits here. So we need at least one rotation. Let's see, can we rotate it around the origin? If we rotate it around the origin, it's going to be looking like this. Is that right? Is that figure J? Oh yeah, that's perfect. That's amazing. Okay, now we just have to move it down. Let's see, and how many spaces down do we have to move? 1, 2, 3, 4. I'm going to do that in a different color so you can see it better. 1, 2, 3, 4. That'll get that that corresponding vertices into that correct spot. And these will all be the same. 1, 2, 3, 4. We don't have to count 4 all times. Okay, so first we rotated. Whoops. We are going to rotate 90 degrees. Clockwise. Let's put a number 1 here. This is our first transformation. We rotate 90 degrees clockwise around the origin. Remember, the origin is 0, 0. And then we translated. That's the other one. I almost said shifted, but that's not the proper word. Translated. How many units did we go? 4? 1, 2, 3, 4. 4 units down. There we go. That's the gist of that. Now, let's develop that understanding a little further. So they're going to have our two methods here, and they're both picture it. So you can start by rotating, then you can translate. Oh, look, that's what we did. Rotate, and then translate. Ta-da! Or you can start by translating and then rotating. So they shifted this way and then did a bigger rotation. I mean, it's still 90 degrees, but you know what I mean. It just rotated a wider circle. I don't know why you would do that. I mean, you can, but I really doubt anyone's going to do that because rotations are more difficult. Look at both pictures. Explain how the figure was transformed in each. Well, it says, doesn't it? So you can start by rotating. Rotate and then translate. This one is translate and then rotate. But should we give the specifics? I guess they both did kind of the same thing. Okay, so the first picture, I'm going to use my typing tool. Probably faster for you to watch, isn't it? The first picture, it rotated 90 degrees. I don't know how to type degrees though. Okay, 90. I'll write it in later. Around the origin and then translated down 4 units. And the second did the opposite. I'm going to use a semicolon because that's fancy. The second, picture it, did the opposite. There we go. I should have capitalized picture it because it's a title. And then I will add in my degree sign because I don't know how to type that. Ta-da! Okay, remember, if I'm going too fast for you, just pause, and you should see if you can do these without me first. That'd be the wise choice. Number 2, look at the longest side of figure J and the corresponding side on figure J prime 2. Are the sides horizontal or vertical? How could this help you decide whether or not to use a rotation in the sequence? Okay, let's look at the longest side. J prime 2. Let's look at it up here. This is a good place to look at it. The longest side is the top. And, well, I guess on this one it's the left, but it feels like the top because it's going to end up being the top. So on the first one, on the original, it's vertical. But on the image, it's horizontal. Dun dun dun. It has rotated. So, how could this help you decide whether or not to include a rotation in the sequence? Well, if the longest side is rotated, the figure needs to rotate. If the corresponding side has rotated, the whole figure needs to rotate. Duh. Don't write duh. Don't write duh in your book. That's not polite. Okay, you can write duh if you want to. There we go. Why is one rotation around the origin not enough? What else is needed? Well, we did it 2 different ways, obviously. If you rotated it first, then it's too high up. I guess we could just write that down. If you just rotate it, it's still way above where it should be. There you go. Is it possible, number 4 now, is it possible to map figure J onto figure J prime 2 if one or both of the 2 transformations in the sequence is a reflection across the axis? Explain. Okay, well, let's see. Can we reflect this thing? If we reflect it over, let's do it up on this. I'll even clean this up a little bit. Let's test it out, shall we? If we reflect it here, now it's over here, and that, can we rotate it that way? Oh, now if we rotate it, it's backwards. The shape would be backwards. Can we rotate? Can we do another reflection though? Let's see. If we reflect it here now, it's going to go down 2, over 1, across 1, up. There we go. Now we've reflected it again, and then if we rotate it again, okay, so we'd have to reflect it twice. We'd have to reflect it from there to there. I'll get another color for you so you can see what I'm doing. If we reflected it from there to there, and then there to there, and then rotated it, that could work. But guess what? That would be a pain in the behind. Why would we do that? So, is it possible to map figure J onto J prime 2 if one or both of the 2 transformations sequence? Oh, not if you only get 2. The furthest you get it is here. You'd need a 3rd transformation. No. Explain. Okay, well, you would need a 3rd transformation after doing, oops, that's terrible. This is why I've been typing it. For goodness sakes. 2 reflections. Otherwise it would be backward because, you know, when your reflection's backwards. So if you only did 1 reflections, it would be backwards. Otherwise it would be backwards. Ooh, my writing's getting worse. I'm going to start a petition for me to only use the typing tool. Will you sign my petition? How can comparing a figure, this is number 5 now, how can comparing a figure and its image help you describe a sequence of transformations that shows two figures are congruent? How do we want to word that? Let's think about it. This can be a tricky one for the wording, so let's see. I can compare the locations and orientations of corresponding sides to see how they moved. There you go. Just like we did up here where we compared the top. So if we just focus on, I keep calling it the top even though it's the left, but it ends up being the top. If we compare where it starts to where it ends, we can see how that line changes, and that helps tell us how the whole figure is going to move. Okay, and this one is for you to do the reflect. I want you to think about the two different ways that they showed us. Really anything in this lesson, what helped you most understand how to solve this try-it problem? Which part of this best helped you understand how to solve the original try-it up there? So go ahead and pause, answer number 6 for me, and then unpause when you're ready to do our practice problems together. Ready? Okay, so we're on page 58 now. We're doing 1, 2, 3 practice problems together, and then you have 2 green pages to do on your own. Okay, number 7. What page are we on again? 58. Number 7. Figure P is congruent to figure Q. Describe a sequence of transformations that shows this and show your work. So if you recall what we just learned above, is the easiest way to start this is to compare corresponding sides. So I'm going to compare this long side right here and see how it's changed. Well, P is vertical and Q is horizontal, so we know we need to rotate. And I see that it's 2 quadrants over, so I can do a 180 degree rotation either way. Does it do anything else? Ooh, is it a rotation? Let's see. No, because look, see on the bottom here, this side is more slanty. This side has a different angle than this side. This side is the slantier side. The corresponding sides are on the opposite side, so it's also got a flip. So I rescind my 180 degree rotation. We're going to have to do a 90 degree rotation. I wonder if we can do it either way. Let's find out, shall we? Let's pick a direction and see if it works. So let's do a 180 degree rotation. Or 180. I just said 90 degree rotation. So we are at, we'll say this is the bottom. So we're at 5 here. So we want to be at 5 here. How many spaces away? This one's at 1. So this one's at 1. And then we're going to go up 1, 2, 3, 4, and down. So 1, 2, 3, 4, and over. This is over 1, so this is over 1. I'm going to fill in all of these lines. Okay, now it's lining up. Or we can just flip this thing over. So we're going to do a reflection now over the x-axis. You could also have done a rotation 90 degrees counterclockwise and then a reflection across the y-axis. Either one would end up in the same spot. So I'm going to do my first one. Rotate figure P 90 degrees counterclockwise, excuse me. Then reflect across the x-axis. You could have also done it the other way, 90 degrees. I said it wrong. There we go. So 90 degrees clockwise and then across the x-axis. 90 degrees clockwise and then across the x-axis, or 90 degrees counterclockwise and then across the y-axis. Your choice. All these exciting choices you get. Okay, number 8. Figure A and figure B are congruent rectangles. Which sequences of transformation shows this? Select all that apply. So we got to go through A, B, C, D, E, and F. We got to try every single one of these. And I'm going to get your pencil and eraser ready. Okay, rotate figure A 90 degrees counterclockwise. So 90 degrees counterclockwise around the origin. So that's going to be that way. Oh, goodness sakes. It's already hanging down here. Then translate it up one. Well, no, that's not close. No. Translate figure A 4 units to the right. 1, 2, 3, 4. There we go. Then up one. Yep, that one works. That'll do. Translate figure A up one, then reflect across the x-axis. So up one, but then if it's reflecting across the x-axis, it's back down where it started. Nope, no good. Rotate figure A 180 degrees around the origin. So 180 degrees, it's going to go, here's 90, it's going to bring it here. And then another 90 will bring it here. So that'll work. That works. Okay, reflect figure A across the x-axis. So reflecting across the x-axis flips it over here. Then reflect across the y-axis. So now it's flipping again over here. And yeah, it's technically flipped over, but because it's not giving us the vertices, labels for the vertices, the shape is the same. It's fine. Oops, why am I doing that? I need my eraser. There we go. Reflect figure A across the y-axis. Okay, so it flipped this way. Then translate it 1 unit up. Didn't we already do that one? It feels like the same as that one. I guess technically it's different. Okay, so the only ones that didn't work were A and C. So good thing we tested them all, because there's a lot of right answers on that one. Okay, here's our last practice problem together, and then you have your green pages on your own. Figure H is congruent to figure H prime 2. Describe 2 different sequences of transformations you can use to show this. Okay, I'm going to make a little chart here. We're going to do the first ones over here, and then the second ones over here. Okay, so what do we want to do? They're obviously facing different directions, so we're going to do a reflection, but we can't do a reflection straight up, because if we did a reflection, we could do a reflection first and then translate it. I guess we have to do that either way, because there's no rotations here. Could we do a rotation? I guess you could do a rotation. You could do a rotation to rotate it down here, upside down. This is a weird shape. And then reflect it up over the x-axis. Yeah, let's do that. Would that work though? That's not 2 though, because it would be, yeah, that would work. I accidentally put it a little bit too high. Let me fix that for you. No, that would be too far over, because look, it's this far away from the x-axis. So if I did that, it would be, let's see, this is at 5, so this would be at 5 over here. So it would actually be over here. Ooh, that's a horrible shape. Okay. And then we'd have to reflect it. So it would be right here. And then we could translate it. Does it say 2 different sequences of transformation? It doesn't say we only can do it twice. So let's do it 3. A sequence of 3 for the first one. So rotate 180 degrees, then reflect over the x-axis, then translate, and we went to the right. How many did we go to the right? 1, 2, 3, 4. Translate 4 units right. Okay, so there's our first sequence. Now I'm going to clean that up. And what do we want our second sequence to be? I bet we could find a much simpler one. I went overboard on that one because I just really wanted to do a rotation. Let's just shift over 1, 2, 3, 4. So now it's a proper reflection. There we go. Now we can just reflect that over. So this was a translation. Translate 4 units right. Then reflect over y-axis. Okay. You could do that in the opposite order as well. The other option that the book probably wanted you to do, probably didn't want you to do this one. But I like it. So yay. The book probably wants you to do reflect across the y-axis first, which would put you, let's see, if this is at 5, it's at 5 on this side, back to where my old one was, and then translate 4 units to the right. Yeah, so, yeah, like that. Any of those will work though. Okay, so do your green pages on your own, and I will see you in class because there's no more develop lessons this week.